Foley from Great Britain. We've been working together for many years on Erasmus projects, trying to bring mathematics and chess into the classroom and preferably combining the two together. He's going to do another masterclass later on strategy games, which is also very mathematical. So, me, myself, I am Rita Atkins. I am the secretary of the FIDE Education Commission. By training, I am a mathematics teacher. I used to do competitive chess as well. I'm a born international master, so you cannot fool me that much if you have any chess questions. So we're not going to do any chess. I'm really sorry to disappoint you. We will be hijacking the chess code and the chess pieces to do some mathematical puzzles on them, so don't expect to play many games. So, yeah, but there should be time after. Just in case you don't know, I brought you the exact definition of mathematics. It's the science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shapes of objects. It deals with logical reasoning and quantitative calculation. This is from the Encyclopedia Britannica, so it's a pretty accurate definition. So that's what you will be doing today. Measuring and describing shapes of objects and lots of counting. When you play chess, you are doing quite a lot of mathematics. Just an overview of what I mean there. There is obviously logical reasoning in chess, a lot of metacognition. That's a very important thing. Thinking about thinking is prevalent in chess as well as in mathematics. Yeah? But broad coordinates, everybody knows that the mathematical and can be used in schools as well. Piece value, screening square, T-squares in pawn endgames, the knight, the binary nature of the knight from left to right. Many interesting mathematical problems are based on that, and also in chess, a lot of chess puzzles use that feature of the knight. This one you might not know. This is the corresponding squares idea. White would like to win and like to break through, but if black keeps going to the same coloring square where white went to, then this will not be possible. However, if it doesn't do exactly that, then white will be able to break through the position. Like when the white king is on f4, if the black king doesn't come to h5 in the next move, then the white will be able to break through and win the game. So this is also quite a mathematical idea. And now comes to the main topic of today. What is chess and mathematics? It's a collection of mathematical games and problems and exercises that we use, and we use it with the chessboard and the chess pieces. Yeah? So this is like a tool to do some maths. And just a few convincing ideas why you should be doing it. Just hands up if you are a maths teacher. Okay? Hands up if you are a teacher in school. No, it's also quite a few of you. Even if you are not, you can teach your own kids, you can teach your brothers, sisters, family members, so you can do a bit of chess and mathematics together. So children who like the chess game, they like the magic of it, they're also very happy to work in chess themes. So if you give them a maths problem which has a knight in it, they think they are playing chess, so that kind of relaxes them. There's a lot of children fear mathematics from somehow that they may have a bad example from school, or they don't like this yes and no type of positions when I have to answer a question. I'm playing a game, I'm playing chess. It puts them in a very nice mindset, so that's one of the reasons why it's good to do mathematics in the classroom through chess. You don't need to be a great chess player, you actually don't need to be a chess player at all. You need to know the rules of chess. That's about it. And of course, game-based learning. There are many advantages of teaching in a classroom with games, and chess is an amazingly good game. So you will hear much more of that in the presentations later, why game-based learning is why we're here. That's why we're doing chess in education. Yeah? If chess wasn't an amazing game, we would go home. There wouldn't be any point of being here. And yeah, so it can be very motivational because a lot of problem solving is present, a lot of puzzles. It often gives this aha moment to the child. Oh, I got it, I understood it. And with that comes that satisfaction, and that kind of fear of maths that often develops goes away. So it's a great feeling of satisfaction when you solve the chess maths puzzle or you won a mathematical game. But overall, it enhances problem solving in a very fun way. And then just some tips how to do these problems. We often work with young children. And many of the chess and mathematics problems are kind of university level problems. So what you need to do is bring them down to their levels. And there are many ways to do that. One way is to simplify the problem. Do it on smaller boards. Also to part solve it. Like you're all familiar with the 8-queen problem, yeah? How to put 8 queens on the board so that they don't interfere with each other. These are called the independent queens. It's not so simple to do. There are 12 distinct solutions. It's not so simple to do it on your own. However, if you part solve it, like there's only 1 queen or 2 queens or maybe 3 queens that they have to put on the board, then it becomes perfectly doable and very enjoyable. And you don't, so all the satisfaction of solving a great problem is there. Many problems use the idea of working backwards from the solution in chess and math puzzles, also in mathematics. And you can practice that a lot here. What is your dream position? What is the winning position? What's the end of this? And then you work backwards to the solution. It's a mathematical problem solving method, and it can be used here in chess and math problems as well. And of course, for the children, talking about the story, always try and give some personality to these magical pieces, and they'll make it much more enjoyable. So the game plan for today, we started a little bit late because of the presentations at the opening ceremony. I've got 6 things to talk to you about. The arithmetic explorations, we'll do it together quickly, and the rest will be hands-on work you do with your partner. We will be doing eating a poisoned apple. This is a nice little puzzle. Counting the number of squares on the chessboard. I know those of you who know mathematics can tell me immediately it's 204, but it's how to do it for primary school children, how to do it for younger children, how to lead through this investigation will be discussed. We play a quick game called Rook Race. If you have time, I'll show you an easy way to complete the Knight's Tour with younger children. There are many ways to do that, but this method is suitable for even 7- and 8-year-olds. And then my favorite one, peaceable queens. We're putting lots of queens on the chessboard in a certain way. So let's carry on and just summarize how arithmetic can be taught with chess. Ever since I discovered AI, I can do nice poems, and I became a great poet myself. In the silence of the board he stands, a monarch chained by cautious hands. The path unclear, the force surround, yet he survives when truth is found. So let's find some truth on the chessboard. You all know about the piece values, so when you do chess and arithmetic, using the piece values in the questions. Of course, you could just use the mathematical bars that they do in primary schools, but how much more magical, how much more interesting it is to use chess pieces. The king doesn't have a value, not because it's worthless, it's because it doesn't come off the board. So we often leave out the king from these explorations. Later, when we play some games, we often attach a value of 4 to the king, because that's usually the value of king in the end game. It's a little bit stronger than a knight or a bishop. So the simplest thing you can do is simple additions with chess pieces. And what is special about these is the grouping. Like the 3 queens grouped together, you're already having a sense of we're doing some multiplication. 3 times 9 is 27. and here, you are grouping them into digestible sums that are easy to add together in your head. So instead of saying 9 plus 5 is 14, plus 1 is 15, plus 5 is 20, you say, I'm adding the 9 with the 1 to get the 10 and a 5 with the 5. 10 plus 10 is 20. It's a trick they use in mathematics teaching in primary schools, and chess pieces are very well suited to that. Some more ideas. Here again, 3 plus 3 and 5 plus 1. Yeah? So 2 6s added together makes a nice term. Exercises you can do. Find the total point value of the white army. 8 pawns. We've got 4 minor pieces, 2 rooks and 1 queen. You're practicing multiplication, addition. I let you do it in your head, the total number. If you want to relate it to chess, set up chess positions and just ask a simple question, who is better and by how many points? Maybe you can answer that for this position.
Oh, well, I've done it. My friend here is. I'm valued.
I don't know. I didn't count, but looks like I'm in a better position, that's for sure.
So that's one thing chess players always have to do is count, yeah? And they very quickly learn not to just add them all together and then add all the armies or the opposition points together. What they do is they remove the ones that are the same from their calculation. So you're already using tricks. So because you only need to see the difference of strength, so you don't need to know the total value. So these are the same, so they can be removed, and then these are the same, so they can be removed, and then you just count the pawns, and that way you can figure out the answer very quickly. Okay. By using the chessboard, you can also improve your addition skills. It's called chunking. I think that's the official term for it. So here, we call this the sphere of action of the knight. All the squares the knight can move to or attack onto. That's the sphere of action. So what does a child do who doesn't do any chunking? They go 1, 2, 3, they add them all together. After a while, when they have seen the knight in action for a long time, they just look at it and they can visualize all the 8 squares and say, oh, it's 8. Also here, they can very quickly add together these two for the bishop, the 13, and so on. So that the chunking, because of the visualization of the board, works very, very nicely. And extremely quickly they realize that the rook is equally strong everywhere, because it has a sphere of action of 14 from any part of the board. And that sort of chunking then also helps them in their mathematics exploration. Yeah, you can also use the chessboard for the area models for multiplication. 2 times 3 is 6, 3 times 2 is 6, and immediately the commutative nature of multiplication is apparent because of the shape of the rectangle. So 2 times 3 is the same as 3 times 2. And if you, instead of rectangles, want to use chess pieces, then you can use pawns or anything else. Another one, write a multiplication sentence with the black chess army. 2 lots of 8 is 16, 4 lots of 4 is 16. Ask the children to set up a position for this sentence. This is called a multiplication sentence, and then they set that one up or the other way around. You give them a position, and they have to derive some mathematical statements from multiplication sentences. Division, very similarly. It's the idea of sharing equally. So share the knights into 3 equal groups. 15 divided by 3 equals 5, or 15 divided by 5 equals 3. Same for the bishops there. You can also use it for remainders. 4 king is left out. 16 divided by 5 is 3, with a remainder of 1. So you cannot divide the white chess army into 5 equal groups because there is a remainder of 1. 7 equal groups, also not possible, there are 4. So the idea of remainders can come visually and quite nicely. So you don't use the abstract all the time. For little children, it's very important to visualize it. And even more important to begin to touch it. So you're using actual real chess pieces and they putting the pieces in this position. And that way, they will inherently and very quickly learn the idea of division with the remainders. Yeah, and the reverse operations from division, we can go with the same diagram into multiplication. And that's it. So these are the little tricks you can do for arithmetic. John, can you please help me hand these out? We won't have time for this. This is called the chess matrix. There's some puzzles for you to do on the chessboard, simply using the piece value. So let's get hands-on and look at some poisoned apples. An apple rests in chessboard's keep, where danger hides in food so deep. Beware the gift that gleams too bright. It may be poison, poison's bite. This is the task. You have a chessboard. Someone put a poisoned apple on H8. You're playing it with your partners. Each player takes turn to make a cut to the chessboard. Doesn't matter if horizontally or vertically. You take off a chunk of the board. Now, if you lose, you must eat the poisoned apple. But how do you lose? If your last cut just leaves the apple, so when you chop off everything, it's only the apple that's left, then you win because you hand this over to your game partner who has to eat the poisoned apple. Okay? So this is the game for you to play. You remember what we said about starting on smaller boards? So I'm going to give you, will play this in pairs. Each of you will get a pair of scissors and one of these. You can chop off some trial boards. Leave the chocolates alone for now. That comes later. Let's start with the apples. And start on a 3x3 board. Yeah? And see who can win. So you win when you make the last cut, because then the apple is given over to your game partner. And then, while you're playing this, I hand you out the big board as well, and then you can also try it on the big board. You have exactly 5 minutes. So, John, can you help me please? So each pair gets one pair of scissors. You want to play? Okay, so cut out the 3x3 board with the apple or 4, and then
you play with someone?
experiment.
He's missing. Do you want to move here? You want to move here so she can move here?
I need two, not just one.
Are we cutting out the whole square?
I think we're just cutting out like just the apple part.
Okay, so you start.
Yeah, I only have 10. I was
Cutting out the
told
apple square.
maybe you can hand over some.
Each one individually.
Hand over apple. I think they want to.
So the last person to get the apple.
Ketchup just wants to supervise. So you can play
Those two files or random.
These are individual.
So with the 3x3 apple to begin with.
Do you want me to cut this
Yeah,
individually?
chop them individually. That's 4 games, enough for 4 games.
The whole
So
random.
chop that up into 4
You can
apples.
put now same turn on both sides, but you can put everything.
You just cut everything.
So you start, you chop off something.
But the whole thing, or just like another one square?
No, you have to chop off a full rectangle.
We're all in college.
Yes, yeah, or 2 or 3. But you either make a horizontal full club or a...
Can I do like that?
Yeah, yeah.
It's a really nice game.
No.
I know. You're trying to make it small cuts.
I don't mind.
I did say that hearing one.
Okay, so keep practicing until you figure out the winning strategy.
No, she said cut it like.
Yeah, but what about?
It's like
Are you ready to play?
No.
Okay? If one to start.
Yeah, that one.
I'm gonna start.
I think she's gonna come around.
Can you start? You need to chop off,
Yeah.
you know, have the full horizontal or vertical line. So you can make this.
Yeah, I don't know.
Here, here. No, you can't cut it into a square. It has to be a straight line. Make a straight line cut.
And you want?
You want to be the last one who has left. Then you can overlap the poison apple and poison her.
No, it doesn't work. We did figure it out.
So I need to cut this.
Okay.
Okay. Okay, now right is your turn. You need to cut it. And at the last, one apple will get an apple, will lose. Something like that.
So you got it. Okay.
So
I kind of get it.
try to cut.
Anyone who thinks knows the winning strategy, hands up and I come and check.
Yeah, so
And then you are allowed to play the big game with the proper chessboard.
So we just cut it. All right.
yeah, you need to cut it some
Alright, so first, whoever goes second.
something like that.
Very good.
All right.
Yeah. And
So
probably
What happens here is that I could
not
hit you
use
won, you
many
win.
chances. So
And if I
cut
get
it
here,
this way, let's say. And so it's your turn. And probably I lose.
you found a strategy where
Yeah? If you understand correctly the game.
Yeah, so,
Okay. Let's try once again with a small one. So we will start. I know.
I'll start.
Starting off.
Right?
Okay, now I can get it. Okay. I'll do this.
I guess. I think we both figured it out.
This whole thing.
I heard from many places the second person who makes the cut as the winning strategy. Yes, that's what you know, right on the big board.
But you know, if I cut it this way, yeah, like this,
Yeah.
then you will cut it
That's what she will do.
and I will know. So my
She's mean, she wants to
cut
win.
it that way.
Yeah.
Then you have no chance to
Yeah. Okay, well done. Now you can play for the
Oh
big
yeah.
board.
So you know, it's a strategy because if I do it in one second, that way,
Yeah,
you will cut it
and then, yep.
and I will lose. Yeah? So in that way, you have not option to cut it somehow, and then I have last chance and you lost. Yeah?
That's right on the big board.
Yeah, I try, but yeah. So
Yep. And then, yep.
we know how it works, but on the big board it will be quite difficult.
First player, second
Okay,
player.
so yeah.
Second player always wins.
You try on small one or you try to big one?
We can do big one. Yeah, why
Big
not?
one, okay.
There is no way for the
Who's
first
going
player
to start?
to win.
You.
The second
You can start. You
player.
won last time.
Let me try. I don't know. Yeah, I idea.
what?
But okay.
Anyone else would like to try on the big board?
I don't know. I do not calculate it.
Yeah, but not.
Okay. Your turn.
Right on the big board.
I'm playing slow.
Or is that already the big board?
you can put as many
Okay,
rows.
so if I do this.
Why you
Same
over
thing,
there so
you need to
hard?
chop off the entire vertical or horizontal. You need to make a straight line across the three sides.
I thought this was free play.
More.
Why not?
I like that.
But you can chop off the large part.
Okay.
I do a little one this time.
We'll see how it's going. Okay.
That's a problem. If
When
you
you're
start
ready
with
to
a
have a
lot
single
of
one, then this is the top.
goods,
Then the apple
Give
gets
it
cut down.
advantage to the
Yeah.
yeah.
But that was the big
So we're gonna do?
I think I have idea, but I'm not sure if it's correct. We'll see.
Yeah.
So like if you go one direction, right? If you go one direction, you can't touch it.
We moved to the chocolate one.
Yeah. Fortunately, it was good choice.
Yeah.
Bang.
You have the last one.
Yeah. It's a. On the
Good game?
Yeah, good game. At the beginning, it's quite complicated.
Yeah.
I'm not aware what's coming.
You want to do this one? You want this one?
Yeah, let's go.
Here, win us first.
Right, first. So no matter what size, there's no much option here. So let's do it in that. If I do it in that place, then I lost.
So I lost it.
So it was this kind of thing. Because I have a choice. I could have kill or kill. Who lost?
I don't know why I added 2 squares. I should have just gave him 1.
Okay, I'm sorry to stop you in your exploration and fun, and it's so nice to see that there is this so-called busy silence where everybody's enjoying themselves playing, yeah? Even though we're playing a maths game. You're not deadly silent, you're enjoying yourself, trying to figure out the strategy. So many of you already solved this, I think almost everybody. The second player wins with best strategy, and you do that by cutting to a square. So you always, whatever the first player does, chops off a straight line, you get a rectangle left, you make the second cut, so the remaining piece is a square. So eventually you will get the apple, that's the smallest square, and then you hand it over to your game partner. And it doesn't matter what size the board is, but we don't go over a chessboard because we are relating to chess. That's why it's called chess and mathematics, so we stick to the chessboard. Now, 2 more minutes to try it with the chocolate on a small board. How does the rule changes with the chocolate?
Nothing.
Hands up if you like chocolate. Okay, and I promise this is not a poisoned chocolate. So you win if your opponent has the chocolate because the chocolate is given that to you. So the winning position is the opposite. That's with the apple.
So with the apple, the second player has to be there?
Yeah.
So the first player is already as a defender?
Yes, it's like it's a game with a known strategy, but children love that because they go home and they beat their parents.
And I try to make it 2 by 2.
So
I guess you
make it 2 by 3.
the question is how to play this with the chocolate. Is it obviously it can't be the same strategy because then you would do.
I guess the first player now.
Some games you do, some games you don't. Maybe this one does. Play it a little bit and see.
Okay.
Ah, dang.
Who is going to start? So this one you are
Messed up. I got it though. We're not even gonna finish. I got it.
okay.
It's like I knew as soon as I ended up.
Try differently.
Yeah, let's try.
So what do
You should. Oh, I can do it in
You should have.
Well, I won because he jumped playing around with it. It's an amazing game.
You want to be first?
So I lost.
I'll be first.
Because and you won.
That doesn't count.
Oh,
So yeah, okay, we know it.
I love you.
So let's start once again. You are going to start?
you can start.
I can start.
You might be cutting
There is not much to do. I can capture.
So you won.
Kind of short. Just do this.
Because I'm not going to this,
Do a
because
short.
then I have to hand over the...
Yeah, we're not, no, we're only slightly,
Yeah, but
along,
also if wrong will work for you because I can buy. Yes, and I won. Something different.
Lose regardless.
So also bad. So let's start again.
yeah, if you, for example,
Anyone who thinks knows the winning strategy with the chocolate, let me know.
you can,
It's giving away to lose.
One or the other?
No,
Second.
this is
How?
wrong.
That's always the second question.
In that way, yeah. Back.
Just do it with the
You
small
win.
one.
No, you lost. I lost.
No, you sure? Because I cut here. And that means you have the last one.
Oh, okay. So
I had to cut this one.
You can't always not make a
Yeah.
square.
Yeah. Okay.
But
Yeah.
let's
So
try. You wanna be a second
thought-
person then, yeah? You said the second person.
Yeah, that's it.
But I'm maybe.
Yeah, a bit.
Some teacher.
My best hole is.
Yeah. And you win. So in a way it's correct,
It
not
only
making a
works
square.
if someone's
Sometimes
not
it's
paying
not.
attention.
Yeah.
So yeah, that is definitely.
Well,
Nope. And then the same thing
And the
happens.
same thing.
And then now you win.
you make this
I'm going to summarize this so that we have a little bit of time for the other games as well. So please look at the board. With the chocolate, it's still the second player who's got the winning strategy. I'm afraid there are games, and you may even see one today where the first player wins. Maybe you won. But there are some games where the first player has the winning strategy. And how do you do that? In this one, actually, the best thing to do is do it on a 3x3 board and look at all the options. Yeah, you will investigate all the options, and the second player will always win by being able to cut a 2x1 rectangle. Because when you cut a 2x1 rectangle, then your game partner has to cut the chocolate out and give it to you. So the aim is to end up with a 2x1 rectangle, and it's always possible for the second player from the 3x3 board. Now, how do you adapt that to an 8x8 board? You surprisingly start with the first strategy with the apples. So you keep cutting to a square until you get to a 3x3 board. And when you get to a 3x3 board, then you do what we've been doing. That's the best way to do it. You may not be able to reach the 3x3 square if your opponent, let's say you added the 4x4 square. So first player is orange, does this. Second player is purple. First player does this cut, second player that. So you are at the 4x4 board. And then the first player says, I'm not going to let you do a 3x3 board because I know then you're winning. So I'm going to chop it down here, creating the 2x4 rectangles. But still loses, because remember our aim is to have a 2x1 rectangle. If I can reach it. I've got my extended hand here. So you cut it here, you've got your 2x1 rectangle, and then you make it. Very enjoyable for children, they love this, especially if you prepare lots of little chocolate bits. Maybe not the poisoned apple, leave that out, but you are allowed to give them a little piece of chocolate. Next one, night tour. Across the squares, the knight will sow a dance of leaves completes the tour. First of all, does anyone know what I mean by night tour? What's your name?
Veronica.
Veronica, yes.
Getting the knight from one side of the board to the other. Or no, hitting every square.
Square.
Hitting every square.
You want to visit every square of the chessboard, but only once, yeah? So you are not allowed to revisit squares where you've been to. There are many ways to accomplish this task. One are more difficult than the others, but there is a kind of a relatively easy way to do it, and we call it the diamond method. So I'm going to show you how to do it. We've got some colored counters, but we may not have enough for everybody, so I will put you in groups of 4 to try and do it. So that's just explaining to you what the knight's tour is. The knight goes everywhere, maybe starting from A1, 2, 3, and so on. This is the so-called edge-hugging method. The knight goes around the sides until all the sides are covered, and then needs to do a bit of thinking and try and do the one in the middle. Not so simple for little children. Now this is our diamond method. They are not really diamonds, they are squares and rhombuses, like mathematical objects. No geometry, mathematics, we're teaching that here. But they like to be called diamonds because it's more exciting for them. And storytelling is important, so you can even have a little story about why the knight is searching for diamonds. So what we do here is we build up the chessboard with colored counters, and then we will do the knight's tour by removing the counters one by one, and when all are removed, then the knight's tour is complete because you've been to every square and only once. So first you divide the chessboard into 4 quarters, or in mathematics we call them quadrants. You can use, if you have a laminated board in your chess pats classroom, then they can even draw on it with a pen, or you can have a thin ruler somehow make the divisions clear. color counters are an extremely useful and very, very cheap essential for the chess maths classroom. I implore you to invest into one of these. So you choose a color and put down square-shaped diamonds in each. Then you do the same for another color. You see my brown ones here. And then we continue building up the board with rhombuses, or here the green-shaped diamonds. They would all come here. And the blue ones, they are rhombuses in the other direction. So I think after one slide, we're ready to rock and roll once you have the board in this position, in this pattern. Why this is a magic pattern? It's because the same colored counters are a nice jump away from each other, and that will really help us to complete the nice tour. So I invite you to somehow merge into groups of 4. And with one empty board, you need, I give you lots of colored counters, and try and create that pattern. I'm not sure if I have enough.
So what do you do?
You need basically 4 different colors. Oh, we need 6 in each, yeah? If you don't have enough rounds, then I will do some more. Now, who is together? You 4 together? Okay, you need one board too. You working? I've got enough for I think 2 more, so you wanna come here?
I think we're joining.
And then that really work on
Yeah, it's 4 here.
Area.
and that's all of you here maybe doing it on this board.
Oh, okay.
Yeah, use red for that thing, and then, so, right, so it's here the,
One color, one player, right?
here.
It's very clear. But you should know.
No.
You shouldn't know the method. It's really very hard.
Well,
So
the
you
ideas
need
are
to get a
building
rank.
quadrants.
Oh.
So within this
Any
quadrant,
method, we can find how many pieces you can with your mind. Give your mind.
like here would be the,
When you can. Yes? Here. When? Here. Okay.
I think it's squares and rhombuses. That's the first
Now,
shape.
where you
I
go?
need to repeat that
Are
here.
we only allowed to have
Could you select the blue counters then?
Yeah,
Light blue?
so I
I
can.
guess so, yeah.
Yeah, so that's C3.
Just pick a color, yeah.
That's where we start from. Then we suddenly kind of start moving to this. Yeah.
Don't think about moving it, just build it up with shapes. So if you do the
Oh,
C3,
so
that's going to be a rhombus there, yeah? So you need to create this rhombus in this quarter, and then repeat that for the other 3.
So from there we just have to then I should be okay, fine, yeah.
Don't think about the night floor yet, just build up
Just
the
the
board.
rhombus.
Just the rhombus. You're doing these rhombuses here. This is the second
We gotta use the same color.
It's important
to be
to
an L-shaped
use the
line.
same
So
color.
basically, I could do this one.
No, first finish. Be systematic, it's important. Algorithmic thinking. Blue for all these. If there is enough light blue, we can use dark blue. Okay. Make sure you put up the same colors first.
Oh, right, yeah,
There's one more.
You don't have to use the same, but
As long as it's
yeah, that's
rhombus,
fine.
yeah.
Rhombus. But you need 2 more rhombuses.
This one? No, it's-
What is the one?
And you can use the other rhombus for the green, but this is, you don't have enough. You are allowed to nick from others if you're missing a color.
You don't have to. Okay. You don't have any more. Yes. So how
So
many?
this one is done.
Count.
So this one is done.
Now we can do black. Or we don't even have black.
To the green ones. Here.
More orange or red. I think we do have more orange, yeah.
See now, if this is parasite from each other, it's a L-shape. Nice one.
It's like that.
30. 31. Without any method? You are right?
So now we're gonna go for
Which one?
square.
Okay? Without any method, you're right?
Yeah. So
This one goes
35.
then also the very nice sense. size for the children.
Sorry to interrupt or disturb. Should we go for one color first?
Okay.
Either green or
Yeah, no worries, okay.
that's our one.
Okay, so then
I study it.
this one not here.
This is a separate, right?
Let me
This is just a quadrant.
give me another pen.
You'd have to finish the orange one.
This one goes. Yeah, third one.
Fantastic. Now we got 4 quarters.
Yeah, not fun.
Right?
This one goes.
On the left corner,
Wait,
That's right.
near
yeah, this.
this one, near this one,
Wait, where?
and this one.
And one last one. You is ready.
I don't think I actually
Shall I
have
make
to,
you an
like,
orange?
at my school or like for our major, we just have to make sure we
So
get 300.
pick another color, maybe green you have enough.
Okay, you have green, you are full green already.
Orange,
Bam.
Yeah, okay.
Bam, bam.
The greens,
blue,
almost done.
green,
Here.
I'm pretty sure
and
I'm
the other
missing.
one, green,
Okay. Here.
black,
And here. So green is black.
orange.
We can use yellow for the last one.
You are double tasking, that's not so good.
That is very, very, very easy. You can copy this one.
I don't think my brain works like the rest of
Here, later here,
That's why,
I'm just
that's
seeing
why.
spots with colors. No shapes. No shapes.
you can copy
All coffee.
Yep.
color. No, you can try on here. Yes, here. This one, good color.
Set, good. Now. And now comes the night toy. Pick a square where you want to start from. There. Okay? Note the color. The color there. Green. So what you need to do is clear all the green ones. But in each quadrant you have to clear them all before jumping over to the next one.
But I need to move here. Or just
As a knight.
No, but we can't go from this to this, can we?
No, that's
Yeah, I agree, but should I move, right?
Yes.
Collect them,
That's it, yes,
move,
yes.
collect,
That's it.
and move, collect,
Yeah,
right?
so one quadrant
So
down.
one quadrant is done, well done.
Okay, for now I need to choose here.
But it's very important to continue with all the green.
Okay.
So you know, I go to A5 and collect and blue. Excellent.
We need black.
And lost.
So that's what we have.
Yeah, so yeah, I agree. So it's a size here, right? So we need to choose
Okay.
here,
So yeah, here, and then here.
yep,
Orange,
here,
very good.
here, and for now I have an option to jump here, yeah, that's good. So let me do green and another person will do another
Black
color.
one,
And yeah,
green, here, green.
there's no other
Thank
way.
you. One, okay.
Yes, all clear.
Okay, so you're ready to go now. Okay, everything is correct. So you need to put the knight somewhere where you want to start.
Yeah,
can pick any
either way.
square.
Something like that, yeah?
Get a knight.
If my understanding
Well,
is
we want.
correct.
So the color is green.
Jump here. What
So
about
your
different
task will
colors?
be to remove all the green counters.
No, we just go on to a different color
Color,
first.
How
okay,
can you
so
do that?
Then that's
No,
the
no,
other
it's
By
not
knight
the
task. The knight has to jump as a
So
knight.
the idea is to go to every square on the board without hitting the square. So once you take the,
And remove them.
this off,
So for now,
You already
let's say
listed 1, 2, 3,
yellow,
4
okay, so
squares.
we do that
Then you go on to the next quadrant.
So
It's very
what's the
very
yellow color
strict.
here?
It was a green.
Oh, just the green one.
You can jump to whichever color you want.
Yes,
Now we are trying to eliminate the yellows, right?
yes. Yeah, because yellow is only the orange.
And now you are stuck because you can't jump the green.
Yeah,
You went the wrong way, so now you need to back.
Except for yellows.
Okay.
It's easy to backtrack
Yeah,
without
because we need to remove the square and not back here, yeah?
So how do you do it so that then you can jump?
Black and brown is the
Yeah, so
color.
that's
Agree.
one quadrant down.
Nice.
You are doing this, so that I know that.
Yeah.
So I have to start on this one.
Okay.
Yeah.
And
and I connected that.
Yeah, that's okay.
You need to make sure that you collect all the same colors, otherwise it will not work.
Nice, nice, nice.
Excellent, yeah?
Yeah.
Just simple,
So
then move on.
here, yeah.
Now I understand.
Nice.
Almost done.
Okay, this is
For the colors, and at the same time, they
Go to orange.
fantastic.
Just in this quadrant.
Yeah.
Okay, only two left. Good. Doing very well.
Continue?
Did you ever
I
have to?
think the blue one is amazing for you.
Fantastic.
Now, I mean, another
White brown.
is, we start here, right?
Yeah.
And from there, if we, now we can, if we were to
Blue.
maintain.
What do I choose? This one or this one?
Make sure that started.
Maybe this will be correct. Finish that part and go here.
Now, the last
Because if like you go here,
You
here.
need to start somewhere.
It's also
It will
possible.
work, yeah.
Yeah, here, here.
Start out.
It also
Remember,
should, it also should work.
you put
Up to you.
30, just 30
Your choice, your turn.
at your first.
You can go here and then you go there. And then you go there.
It's also here, 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 here. Yeah. It also should work.
Oh, you need to be in it.
And then jump over to the next square.
Why?
Because in the dark, it doesn't look like this.
All the yellow one. Then you
Oh.
You do last one? You do last one.
Yeah.
Orange.
No.
And here.
Finish the next one.
Over here. Yes, you are.
Well, but you already did that.
No. Oh.
Green.
Yeah.
It does not matter, I think.
Why did you do that?
Yeah, you can go. You can go.
Well, no.
Here, I think can be fine.
Just maybe go here.
Yeah.
We've done one, and then instead of going here, you come here.
You can also go here.
But then you go here.
You can't go here. You can't get the
There is no orange, yeah, so you need to start here. Yeah. Yep. Good point. Good point.
Well, no,
Yeah, and only this is available from here.
Did I do this one?
It's very important to see me in the sun.
So we can do it here.
Sometimes it's the light and I'll
Right. So
Francisco Cruz y otra sierva.
Now which way? No, you need to see.
Put your, where you want to put it?
around to this one.
Listen, because now start the magical mystery tour.
see dark blue.
Magical mystery tour.
Okay, good. There's only two colors left. Now.
So we can go.
Now,
There, yeah, because you don't want to.
Yeah, so I'm trying. Yeah, so I'm trying right
fantastic. And now you must think.
And then.
And this is the way knights move in the room.
Yeah, just
Now we start to another part. Fantastic.
so here.
So we go here.
That's it.
Okay.
Keep going.
Carry on, you know.
No. Listen, no. What can you do? Because after me,
And the first one is complete. Well done.
go to the other part. So
Very interesting with small cookies. You can then do the once they've done it a few times, you can do the opposite. I'll start with an empty bowl, then build it up.
then the last.
Then the
last one, this one,
You got
this one,
1 minute, maybe.
and a stop.
Yes, it's
So she basically took the redo, but this time she took for like the smarter cake. They would have to start with this, put a color, and then basically try to make it
Now,
But she was like, we have a minute or two.
now thinking about, you must take the other. Perfect.
It was written by ChatGPT.
Perfect. Perfect. Now, what happened now? Very difficult question.
Well, I
You're
got,
taking all the approach.
I trapped myself.
And now
Yeah.
we then take another color. We need to compete. Which kind of color? The first color in chess. Which color do you want? Orange.
You're over here on a,
For this.
Stop on it.
It's possible. It's possible. Okay.
I just need to remember which way they
I know, সেই জন্য তো আমি উঠে আসছি।
Okay, okay. Okay, Maki. Okay, Maki. Hey, no.
Finished? Yeah, done. And a little bit harder is to do it the other way around.
When you
start somewhere and you need to build it back up.
jump to the other one.
The colors.
To look at.
You have to watch for which side it actually go.
Yeah. It's a much harder exercise than bright children, you know, or after having done this a few times, they should be able to do that. And it's very good. You build backwards up to,
Perfect.
and you can pick it that way put the color counters back.
Okay.
You have to imagine your square, what is here, this is going to be a square, yeah?
keep the night, keep it all the way the night moves.
And now stop. So then think.
I'm afraid that's all the time we have for this one.
Which color do you want to use?
So you have to use that one.
Black?
This works so nicely in school with the shoulder tapping.
I don't know. Black and black.
until 51 flags.
So this is all the method of collecting the same colors, but you've seen it in the video list, so I don't want to spend more time on this. Yeah. There is a way to gamify this because we like doing investigations, but we also like playing games. So now the game is you're moving the same knight. We won't be doing this, but it's homework for you to try. You use the same knight of two players. So what you do is you try to complete the knights too, and then you get whoever cannot make a move will lose. So you start here, then you put a counter down. Then you move somewhere, you put a counter down, and you alternate, yeah. Usually, without any systematic method, you can probably cover about 40 squares on the chessboard, and then you get stuck.
You can't
Or if you use a systematic method, then you can complete the knights too. I'd recommend this to be played on a smaller board again, only a 4x4 board to begin with. And the winning strategy is quite interesting. It's basically, you've got to imagine these 2x4 rectangles, both a larger board and a smaller board. And the way to win, this is for the first player, is to keep in the rectangle. So you have your imaginary rectangle, and you must make a move which keeps you in the rectangle. So if the knight started here, then this is the good move, because then your game partner has to move out of the rectangle. Then you keep in the rectangle, he has to move out, and then you keep in the rectangle, you will always be able to make a move while your opponent won. This you need to try. It takes quite a bit of time, but it's worth it, I think. It's a bit, it's very difficult to grasp this idea.
Yeah, I'm just thinking, similar to Connects 4, we need to think where we put the checkers that the opponent can't actually make the connection.
Exactly, similar way of thinking. Yeah. And then once you play this a few times on a little one, you can move on the next. So you see here, the knight started here, so the first one will stay in the rectangle. Because there's only one knight move in this rectangle. That's why it's 2x4 rectangle. You cannot make two knight moves within that same rectangle. You need to move out in the second move. So he has to move out, and then I stay in it. So number 3 is up here. Then the player again has to move out of the rectangle. And then you stay in it, and then you already then won, if this is the game, because then the knight's already been there and then can't come out. So try it. Yeah. So this is the knights 2 gamified. A little game to play with a single knight. Okay, how many squares on the chessboard? On the checkered field of black and white lie 64 squares gleaming bright. A quiet grid, so calm, so still, yet home to battles, sharp with skill. Another great point from ChatGPT. I hope you like. Okay. So, how many squares? Ask the children this question. How many squares can they see on the chessboard? What will they say? What is the most obvious answer? 64. The others say 1. The big board, or they say 64. 64 little one. But then you can explode that. You can have 2 by 2 squares, 3 by 3 squares, 4 by 4 squares, and in mathematics, very often is the counting things systematically is a skill that we need to develop. And that's the skill you can develop here, and also some sort of pattern recognition. So I invite you to complete this exercise by counting how many 1 by 1 squares you can see, how many 2 by 2 squares, 3 by 3 squares. These diagrams down here will help you with how many there are. And I can also give you empty chessboards. You've got your scissors to keep chopping, so you can actually try out how many you can fit on the board. Okay? This one is for everybody. Let's spend 5 minutes on filling out this table.
Thank you.
Thank you. এখানে মেইনলি হচ্ছে how this connected problem solving over chess.
But a few more. So here's the board you want to try out. You know, this starts from
Oh, I see.
cut out a 2 by 2 square maybe here, and then see how many times you can fit it on the chessboard. And that will be the number of 2 by 2.
The 1 by 1 is, I guess,
So maybe you can hold here, you can use that.
but I think the 8 by 8 is the whole thing.
If you want to try out the techniques, like 1 by 1 is easy, that's easy. Yeah? The 2 by 2, cut out a 2 by 2 square from here, and try and fit it on this chessboard as many times systematically as you can. No, not this one. Cut it. This should be your big board, and cut them out from maybe from this one. So the remains of the old.
Come on. That's not very good.
If you need to chop out some squares, you can use one to chop them up, and the other one to. You can chop up 2 by 2 squares, and then.
Good, yeah.
Because 8 by 8 is the. But I'm not sorry.
I thought it meant how many
Every 4, right?
you fit. You not just like make
Every 4, right?
What is the first one?
Because the 1 by 1 is 64. Oh, it's how many you do it.
7 by 7.
5, 7 in the draw, no. Again, 14. But you need to know calculate that way.
Like this,
Square side is 1 by 1. 1 by 1 means if I show you on the suppose this is 1 centimeter.
multiple.
By 1 centimeter square. So that's what it's
I was
2 by 2
trying to
here. That's your
Yeah,
yeah, that was the thing. So I was like, and then there were some falls and clubs and stuff.
How many?
that would be like the best.
Yes, just to give you a message. The only problem is my downside is I'm in college, so I'm not sure will I be able to.
I recommend you do the cutouts, yeah. Because you're obviously teaching it.
No, that's fine. Yeah,
of course, yeah. That's a square. Yeah, but this is a square as well. Yeah. So how many times can you go? 7 times. And how many times can you go sideways? 7 different. 7 sideways.
I think it should work.
7 by 7. It's 49.
And this is high school stuff with these guys.
But 36. I don't know if I counted it wrong.
It should be 49.
Oh, shit. Oh, you just flip-flop.
Yeah, he already did it. So I think it's solution here, yeah.
So did you find the pattern?
Yeah.
Oh, I was wondering how you finish all. Okay.
Clever.
Excellent. Show me, please.
Yeah.
Show me. Okay. And you like the pictures?
We know the 1 by 1 is.
See? So can you already make the second one? Nice.
Oh, you need the positive.
Can you explain on this?
Here is all it.
Oh, you. Can you explain?
So here's 3.
So what's the third one then? Is it just 4?
How many for three?
So that's going to be. Yes.
You must see.
Just going down.
For example.
Just look. This is a 3 by 3 square. That's the third row. Yeah. So let's get the big square. How many times can be fitted on? Starting with the corner. 1, 2, 3, 4, 5, 6. And then we go 1 up again.
8 by 1.
Because now it's just like extending the line.
6 times. 6.
Okay.
It's a slow chase. Right? This is where we're at.
Here is 2.
It's time to wrap this one up, so let's discuss the solution. If you are going to try this in your chess maths classroom, please use cutouts. Let the children cut out 2 by 2, 3 by 3, 4 by 4, all the way 7 by 7 squares, and then we really see how systematically you can put that on the board. And then they will fill this up. And they also recognize, we love patterns, we love pattern recognitions in math. So they recognize that they are all the square numbers. Yeah, and they add up together, you get 204. This is just to impress them that in mathematics, that's how we sum up square numbers. And there's also a formula for the sum of the first n numbers, but you can look it up on Google if you want to. Anyway, this is a lovely, lovely investigation because it looks hard, but if you're actually doing it physically on the board with little cutouts, and all you need is a paper print, yeah? It's not something magical you need. Then it's very satisfying for the children because they actually understand how to do it. Any questions about this? Another typical chess and maths exercise, investigation, we're using the chessboard. Rook. On a checkered field of black and white lie 64 squares gleaming bright. Quiet grid, so calm, so still. Oh, that one, you already heard that one. I think they copied my rook point wrong. This was supposed to be a rook point. They redid my slides, so that's my mistake. Anyway, apart from poetry, let's go to the game. Another game for you to be played in pairs. Remember, we like playing games a lot, not just doing investigations. This is called the rook race to the corner.
you're playing it with a single rook. So both players will move the same rook. The rook moves either down or to the left. The rook is looking to get to where the smile is. And whoever gets the rook there first wins. Same question as with the apple. Who's got the winning strategy? What is the winning strategy? How are you playing? So we always start games with 3 explorations. So just get started and see. Maybe you can come up with some conclusions on your own. You can use the colored counters, one of our magic counters for the. Just one.
That's one.
You move in the same rook. You take turns to move the same rook. Okay, just one rook. And you need this. You can start.
So basically, no, you don't use one of these. I think you're just trying to get here as fast as you can.
Okay. But you are there.
Yeah.
On the left or down?
I guess you can find it. It's fast. Because all you gotta do is. But you can also do more. She said.
Play with your father.
I don't know. Maybe you could go. That's more. That's 3.
We have to get like you always have to go closer to it, so you can only go this way or you can go down.
So what's the strategy? How many squares I can move?
I don't know, because right there it says how fast you can get to this one.
Yeah, for now.
Yeah.
2 moves.
Where is your target square?
And I was like,
You can't go back.
I was saying we could just go like 1,
Where is your
2, that's 3. Yeah, that's 3.
But depends now. Look at the arrows. Is it indicating that one is square is fine?
It's a game, it's a competition. It's always. No, that's why I said you can't go backwards. You want to
Oh, then let's restart then. I didn't know that.
Do you need that?
How many squares do you want?
It's a rook.
So you move up and down.
The last is we can have.
But now you start.
You can only move past as the rook moves, then your game partner makes a move.
That's not backwards.
Then you make a move and then your game partner wins. Whoever gets
the same rook, yeah?
The same rook. And whoever gets there first wins.
If you do it's your turn, yeah? If you move
That's a losing
then I
move.
won, yeah?
Yes.
So you need to
I'm
do
gonna make
something
my
like
partner to.
Oh, like different, so you can do it.
Yes, of course, because you want to get there. You want to get there.
Oh, okay.
It's a rule, yeah. For now we got it, yeah?
No, I'm moving it. Okay, okay.
But I'm more thinking I don't want you to get there.
8, 2 you. Put color when you stop.
And then I can try to mess you up.
Yeah, so it's your turn, you start.
No, you can't go backwards.
Okay, so I would have right here.
So yellow is your turn. Basically,
That's easy.
I think no, I think it's no, I think what we're trying to do is get this. So since I go here, you can go. But I guess if I go here, now you can go here.
yeah?
And then I can go somewhere else. Alright, now we know.
Or snakes and ladders. Whoever gets here first, then what?
You can do that.
Okay.
was the first
So now,
Let me think.
You make
you can go back.
what is the best?
So what you are playing? Is it?
When I move,
Maybe.
It's a point.
Yeah.
So you put here or here.
I think backwards.
Anyone who thinks forward strategy,
Can you, when you're right here, can you move backwards?
no,
Does it have to be?
otherwise it would.
No, yeah.
Otherwise you would get out of any bad
So
situation.
best room for me is here, and I won, yeah?
And then you
Just let me know. Okay, let's start once again.
If you're actually paying attention, because you wouldn't normally is there a way?
I'll do it. I'll do it.
Now we're going to strategize here. Yeah, sure. If I do this, you gotta go back. So if you have those,
You're Charlie.
So final goal is to
It doesn't matter until you get there.
Yeah, so if I
Or I could have just gone forward.
Yeah, then it.
Yeah, the goals to get it, but not to get enough to
It's slow.
But then you could just skip ahead.
Same
Oh, yeah. Like theoretically.
Thank you.
Losing strategy for you.
Yeah,
So in that situation, there is no option.
There is no.
So
I'll go.
And then you can just go, just skip it.
Yes, still no.
And then it puts you on the
Oh,
yeah.
Yeah, he's.
Yeah,
No, because if I go down, then you can
goes back more.
Let's discuss this, because I want us to have a little bit of time for my last one favorite one, the peaceable queens. Many of you got it right. The second player wins. I'm sorry I only brought you games today where the second player wins. I need to learn from that. Do a few games with the first person as well next time. Now, so basically the second player wins by always moving onto the diagonal, the main diagonal, yeah?
Yeah.
Okay. Instead of telling you the strategy, let's do the thinking bit. Again, working backwards, starting from an almost finished position. So maybe when the rook is here, who wins in this position? Second player, because you either go to A to a B1, and then the second player will get the smiley. Now let's move on a little bit. Let's put the rook on C3. Who wins here? First player or the second player? Second player, because either the first player goes to C1 or A3, and then the second player gets straight to the smiley. Or if the first player goes to C2 or B3, and the second player goes here, where we were, and we already discussed that, so the second player wins that. So you see, the rook, when the rook is in the diagonal, the main diagonal, then it's always the second player who wins. So going back all the way, not back to forward. Oh, that was the last one, okay. So if you go back all the way here with the rook, it's just the same strategy. The first player moves somewhere, the second player just needs to return the rook to the main diagonal. And then the first player goes here, maybe A4, then we return to the main diagonal.
Okay,
and the second player
that's nice.
Now, interestingly, you can play this same game with a king, with a single king. Try it at home. There the first player wins with that strategy, but we don't have time to discuss it. So with the king, the same way, the king has to move always, as a king obviously, but always getting closer to the target square. You can also play it with the queen, but the queen shouldn't start here, because then obviously the first player would just move it straight to A1 to win. We usually start on H5 with a single queen. And that's another similar game, trying to get the queen to the corner. And then you can also play to the collection of pieces. Like you can start with a piece from somewhere, another piece from somewhere else. But it's important that the pieces are shared by the people, so everybody, both players play with the same pieces, so the same colored pieces. These are very interesting mathematical games. This was the simplest one I showed it to you, but there are many, many more from here. Any question about the rook race?
I guess as the first player, you're kind of just relying on the second player making a mistake.
Yeah, because if the second player doesn't know the winning strategy, then you can still win, because they make a wrong move, then you get the rook onto the main diagonal, definitely. The same with the apples though. But don't underestimate games for children where the strategy is known. So once they learn the strategy, they can play it with all the authority figures in their life, their mummies, daddies, grandparents, and they beat them all because they know the strategy, and will give them immense joy and satisfaction. And the last one, peaceable queens. Unfortunately, I got the rook there, but imagine that's a queen. At least they got my poem right. No blade was drawn, no woe begun. Their words outshone the blazing sun. In silence spoke their might and will, and warrior queens grew soft and still.
So we know queens are aggressive warriors on the chessboard, and here they will be peaceable. They are not going to interfere with each other. A beautiful mathematics problem, peaceable queens. We use it, I think, very, very well in primary school maths lessons, and we can also gamify it. I'll show you how to gamify it at the end. Now, so what are we doing here? We are putting as many queens as we can on the chessboard. The first player puts white queens, the second player puts black queens on it. They have to be the same number of queens of each color. So if there are 2 white ones, then we also have to put 2 black ones. And the key is that they are peaceable, means that the white queens do not attack the black queens and vice versa. Yeah? So they are peaceable, they cannot capture each other. One army cannot capture the other one. It's very good to do this on a smaller board first. This is the solution for the 4x4 board. Let me show you the other size. This is the 3x3 board. That's obviously easy. You can only put 1 black queen and 1 white queen up in a knife jump away from each other so that they don't attack one another. You've seen the 4x4. This is the solution for the 5x5. You can have 4 of each. And then, yeah, this is the 6x6 board solution, or one of them. I think there are a few more. Can you see that they are in nice, kind of almost symmetrical chunks? And if you take a moment to look at the diagram, you see that no white queen is in the sphere of action of any of the black queens and vice versa. That's the 7x7. That's the 8x8. Please don't move on. Crazy mathematicians then go up to 9x9, 10x10 and all the larger boards and try and figure out the same. Now, what can we do with it? Just showing this to the children is not going to derive a lot of fun for them, yeah? So we need to make this into much more interesting investigation. So I would ask them to try this. You can also part solve, so you put a few queens down and ask them to fill out the places, find a place for the remaining queens to make it a solution. Remind them always that it has to be the same number of white queens as black queens. And then once you've done a lot of this with smaller boards, then we turn our attention on an 8x8 board. We start with a free exploration, so ask them to do it. Like maybe it's 12 o'clock, we're supposed to finish, but I'm more than happy to stay for another 10-15 minutes. Are you okay with that? You can leave if you want to, but yeah, so that we can finish. This is our last problem, but it's quite nice one. So why don't we start with a free exploration? I'm going to turn off this diagram. So quickly go backward, maybe, yeah. And using colored counters because you don't have enough queens. Try this. You need 2 colors. With your partner, as many as you can, but the opposite queens cannot capture each other.
Eccentric movement.
Right, exactly.
Concentric to take it back because I got it wrong. Isometric because I'm stuck.
It's not a game, so you can work together. It's like an investigation.
Right now I'm approximately trying to
8x8. Yeah. So on an 8x8 board. 8x8 board. Yeah. And it's not a game, it's an investigation. You work together. How to place the queens, as many as you can. Same number of each color.
Have you tried stretching? Do you ice? Do you elevate? Do you elevate?
You can use phones or
so when you're elevating, you should be icing.
What is this?
Is it still swollen or is it just hurting?
Putting down these These are like
I can't
queens.
place you until you're gonna capture.
So what do you
Are you
think?
doing
Yeah, so it's gonna go L shape.
You don't want the gun to take you, so I can't do that.
No, I can't go
We
here.
just want to put as many down as we can.
I mean, you could have also
The problem is though that whenever you sprain your ankle to a straight like that, it stretches your ligaments. And so as they're starting to heal and go back to normal, you start to experience tightness. When you're reducing your range of motion. So that's why physical therapy is important, because we know it helps them to be able to allow you to regain your range of motion in a way where it's not overstretching it or like causing strain on the ligament. Yeah, a lot of people don't, or a lot of people, like, I guess depending, people have minor sprains, but like for more severe ones, they just try to for themselves. Some people can, but without proper like exercises and stuff like that, sometimes you could cause more harm than good, and you could be at risk for spraining again. Yeah, I mean,
Yeah, so that's already a solution. But it's the
even if
1,
it
2,
did
3,
take time.
4, 5.
So a little bit of like seriously, exercise can do a lot.
Oh, sorry, how did I miss the?
Fantastic. Very good to see.
So what's the point? What are we doing?
কোথায় গেছিলাম বুদাপেস্ট ওই যে একটা ছিল আমি যে করতে পারি না was it Budapest?
7 and 7.
কি ছিল ওইটা under 16
Did you want to be together?
Now, can
হ্যাঁ
you
ওই
improve
অলিম্পিয়াডে
that?
ছিল একটা পার্ট অফ টিচার্স
Can you add one more?
37, yes. This is the kind of problem that my field does in computer science, optimization.
Yeah, it's about
One more.
We've seen a 7 by 7 solution. Does anyone have a long?
I know you would think, but then.
Because I'm going to say to you this, I'm going to ask you a question.
Why did this one get to be green?
Perfect. Now, 7 again. Are you going to be working the slides tomorrow too? And you need to put 5.
No, not. Okay, so you had the pre-exploration phase. I've seen a 7 by 7 solution.
Now we have
Rita.
9 by 8.
9 by 8 is not a solution because you have to have the same number of white as black. So I've seen an 8 by 8 solution over there, which is pretty impressive.
8 by 10.
A 9 by 9 is the maximum. Here is one here. It's very difficult to find it on your own. Really, it's a lot of.
That's an algorithm.
But we can still use this problem for a mathematics classroom in the chess room without asking them to find 1 or 2. I think that's really from 9 by 9 solution. So let me show you a way to work this in the class. Okay? Children, everybody, I want to see your eyes looking at me. Thank you, thank you, thank you. Okay, so I'll show you one way to use this in the chess classroom. You put on one of the armies. So this is the solution for the 9 by 9, half of the solution, because I only showed you the position for the white queens, and now the children have to figure out the positions for the black queens. Okay? I'm sure you can do it, but let's see how to work with this systematically. First, ask them to draw the sphere of action of the white queens. That's all the places that the white queens hold under attack. Use colored counters, again our magic tool for the chess maths classroom. So they use colored counters and put it anywhere where the white queens attack. And this is the pattern they will get at the end. So how do you carry on from there? You count the free squares. These are all free squares. They are not under attack. How many are there in this? 10. Well, that gives me a little bit of flexibility for the black queen. So there are 10 different solutions here, depending on which square you leave out. Yeah? One square you leave empty, and all the other 9 squares you put the black queen, and you got your solution. So that's one way to work with this. There you are. Here I decided to leave out the B4, so there is one solution. And then you can do that with the other way around, giving the black queen's position. That's another solution to the problem with the 8x8 board.
Sorry, yeah.
You will be getting
The presentation.
presentation if you sign up. I don't know what was the arrangement, but you should be getting the presentation email to you. So here I give you the position for the black queens. You do the same thing with some colored counters. I use blue one here. All the squares where the queen's attack need to be covered. And now you have how many free squares? 9. Here there is no option, so all those squares need to be occupied with the white queen. It's a different solution to the other one. Here you have 3 clusters of white and 3 clusters of black queens. And that's then the final diagram. And of course you can do that with the smaller boards as well. So very nice way to work with the visible queen.
Now here's something interesting. The solution does not have axial symmetry. You can't interchange the white and black queens in there so that they're the same. But the 6x6 solution does have axial symmetry.
Shall we go back to the 6x6?
Yeah. So we go back to the 6x6.
It's over there.
Oh no, I'm wrong about that actually.
No, that's
sorry,
not.
I thought it was not symmetrical. The corners are not. So that's interesting.
5x5.
The 5x5, yes, that has axial symmetry. Okay. So do any larger boards have optimal solutions that are symmetric? The answer might be no, and that gets into the kind of mathematics that my field does for research. That's a challenge to prove.
Can you tell them please what you do?
I'm a computer scientist and combinatorial mathematician. So this is the kind of question. Symmetries are very important to what I do. So that's a challenge question. Can you find a solution that's not only has the maximum number of queens, but is also symmetric?
What's the largest board you are investigating for?
I don't know, but I've done this, I've never heard of this particular problem. But it's the kind of questions that we like to ask. Getting into mathematics, well, or human thought to solve it, yes.
I have a question.
Okay, thank you very much.
Thank you.
So when you showed the solution, you started with like placing all the one army of students. But then like the challenge is like even while placing the first army, like how do you visualize? Do you like, since the queens can go across the board, do you like divide the board and then try to determine the placement?
No, I would just systematically get my counters and say, is this square under attack by some? Yes, then I put the counter there. So I would. And they're quite good at that, because if you do it square by square, one by one, they can always find the queen which attacks it or doesn't attack it. And a final thought, and this is the last thing for today, is let's try and gamify this. Now it's not a problem-solving exercise for children, it's a game for 2 players. So very easy way to do it. You've got first player with the white queens, second player with the black queens, and they take turns to put a queen, to place a queen on the board, but they must always place it on a square which is not under attack by any of the opposite colored queens. So the position will be a peaceable queen kind of position, probably not the optimal one, but very quickly one will run out and won't be able to place the queen anymore, and then the game is lost.
And for example, this is for primary students, and
Yeah.
If it's first grade or second grade, maybe you get only to the 5 squares.
Yeah, yeah.
And then on 5 or 6 grade, then you
Then
challenge them to
Then you
go.
challenge them for larger boards, yeah. So you can really nicely differentiate between ages and skill levels with
So
these. And always,
is it actually possible, because we are actually struggling, because she put 7, I could not put my 7th, and as you suggested, I covered all where possible at Academy from her, but nothing available, so that means I lost. Or is it
no, are you talking about now playing it as a game, or you doing it as
the queens one.
As an investigation.
Investigation.
So you have your 7 white queens up, yeah?
Yes.
In a certain position. If they are in a not ideal position, they may well be that all the squares are under attack and you won't be able to put a single black queen on.
So it's a possibility, yeah?
It is a possibility, yeah. They have to be very nicely organized. Already 5 queens can cover the board, so I think that every square is under attack.
All right.
So when you have 7 in a kind of nice spread out way, they're very likely to have covered it all. So you need to put them in tight groups, clusters.
Makes sense. Thank you.
Right, that's all I had for you for today. Thank you very much.